In this video, we are going to discuss how to solve problem based on a uniform horizontal bar which is attached to a wall and supported with the help of a cable. We will discuss how to calculate tension, angle or mass of the bar in problems like this. Question 10.80. A horizontal bar that is 2.141 meter long and has a mass of 81.95 kilogram is hinged to a wall. The bar is supported at its other end by a cable attached to the wall, which makes an angle of theta equals 38.89 degree with the bar. What is the tension in the cable? So here in this question, you have a horizontal bar that has a length L of 2.141 meter. Mass of the bar is 81.95 kilogram and it is supported with the help of a cable that is making an angle of theta equals 38.89 degree with the bar, and we need to find the tension in the cable. Now if the bar is in static equilibrium, that means the net torque acting on the bar must be equal to 0. So when we say net torque is 0, it means that torque which are counterclockwise must be equal to torque which are clockwise. Now, what are the forces producing the torque? The first force is force due to gravity, Fg, which acts along the center of gravity of the bar, which is at the same position as the center of mass. Then you have the tension in the cable, T, and this force of tension makes an angle theta with the bar. Fg produces a torque which is counterclockwise as it is pulling the bar down, so the motion will be counterclockwise, whereas tension produces a torque which is clockwise. So once we identified the forces producing this torque, we can write the magnitude of torque. We know torque tau is given as Rf sine theta, where F is the force producing the torque, R is the distance of the force from the axis of rotation, and theta is the angle between them. Counterclockwise torque is produced by force due to gravity, and its distance from the axis of rotation, which is at the hinge, is L by 2, which is half the length of the rod. Because force due to gravity is acting at the center of gravity, which is the same as the center of mass, and center of mass for the rod is at the center of the rod, and therefore its distance from the axis of rotation will be L by 2. The angle theta Fg makes with the bar is 90 as it is pointing vertically down. So we can write for counterclockwise torque as R will be L by 2, force is Fg into sine 90. That will be equal to clockwise torque is produced by the tension in the cable. The cable is attached to the other end of the rod. Therefore, its distance from the axis of rotation will be the total length of the rod, which we call as L. So I can write for clockwise torque R as L. Force is the tension in the cable and it is making an angle of theta with the bar. We want to find the tension, so let's rearrange the term. I'm going to divide with L sine theta. So you get L by 2. Fg we can write as m into g. Sine 90 is 1. Divide by L sine theta. That gives you the tension T. So let's rewrite this. I write tension T to be equal to, we can cancel off the L here, mg over 2 sine theta. Now let's substitute to calculate T. Mass of the bar is 81.95. G is 9.81 over 2 times sine of the angle theta, which is 38.89. That gives you the tension T as 640.25 Newton. Now, whenever you encounter a problem which is exactly the same like this, that is, when you have a bar attached to a wall and supported with the help of a cable without any external weights added to it, exactly the same like this one, the tension T is given by this expression. And you can directly use this expression to calculate any of the missing quantity. So you can find tension, you can find the mass of the bar, or you can find the angle theta the tension makes with the bar if you remember this expression. Next is question 10.81. A horizontal bar that is 2.261 meter long and has a mass of 82.45 kilogram is hinged to a wall. The bar is supported at its other end by a cable attached to the wall. The cable has a tension of 618.8 Newton. What is the angle between the cable and the bar? So again here you have a horizontal bar that has a length of 2.261 meter. Mass of the bar is 82.45 kilogram. Tension T on the cable is 618.8 Newton. And we need to find the angle theta the cable makes with the bar. So we follow the same step as the previous problem. If the bar is in static equilibrium, we know that net torque will be zero. If net torque is zero, that means torque which are counterclockwise must be equal to torque which are clockwise. The two forces producing torque over here is the force due to gravity Fg. And since Fg is pulling the bar down, it is going to produce a torque which is counterclockwise. Then you have the tension T on the cable, and this tension will produce a torque which is clockwise. Then we already know how to write the magnitude of the torque. Torque tau is given as Rf sine theta. The distance r for Fg will be L by 2 as it is acting at the center of the bar, and distance from the center to the axis of rotation will be L by 2, whereas distance r for tension T will be the length L of the bar as the cable is supporting from the other end of the rod. So distance of tension from axis of rotation will be the entire length of the bar. Now we substitute that here. Counterclockwise torque is produced by gravity. So for R we write it as L by 2 Fg sine 90, as the force due to gravity is perpendicular to the bar, equals clockwise torque is produced by tension. So L T sine theta. We need to find the angle theta. So I'm going to divide by L and T to keep sine theta alone. We get L by 2. Fg can be written as m into g. Sine 90 is 1 over L times T equals sine theta. Again we can cancel L and L, and so we get sine theta to be equal to mg over 2t. Now let's substitute. Mass of the bar is 82.45 kilogram. G is 9.81 over 2 times t, which is 618.8. So you get sine theta to be equal to 0.654. And if I want to find theta, I will take sine inverse of this term, 0.654. That gives me the value of theta to be equal to 40.81 degree. Now remember, when you're making this calculation, your calculator must be in degree mode. In all the problems that involves angles in physics, the calculator must be used in degree mode. Now, like discussed before, this is a problem that involves a bar attached to a wall and supported with the help of a cable. And I told you that the tension T for such cases is given as mg over 2 sine theta. You could have directly used this expression to find the angle theta. Like I can rearrange this to write sine theta to be equal to mg over 2t. And that is what we got here while solving it step by step. So you can just remember this expression to arrive at your answer in case if you have difficulty writing all the steps. Question 10.82. A horizontal bar that is 2.381 meter long is hinged to a wall. The bar is supported at its other end by a cable attached to the wall. which makes an angle of theta equals 42.75 degree with the bar. The cable has a tension of 599.3 Newton. What is the mass of the bar? So here in this question, we have the length of the bar as 2.381 meter. Tension in the cable is 599.3 Newton. And the angle theta is 42.75 degree. We need to find the mass of the bar. So as this problem is similar to the one we did before, I'm going to directly use the relationship between tension, mass and the angle theta. We write the tension T as mg over 2 sine theta. Now I'm directly using this expression because in the previous two problem I showed you how to arrive at this part. So you can follow through the same steps to arrive for tension T. Then we rearrange to write in terms of the mass m. So we divide with g and multiply with 2 sine theta. You get T times 2 sine theta over g equals the mass m. Now substitute mass m will be equal to tension is 599.3 into 2 into sine of the angle 42.75 over g, which is 9.81. That gives you the mass to be equal to 82.94 kilogram.